Have you never asked the question, what's Docker? No, not this kind of Docker. And well, most people, they don't know.
Now let me tell you a story about the Kool-Aid. Now this might just be the best Kool-Aid you have ever drank. So today, we're going to talk about how to install cool things using Docker on your home lab. Docker has a lot of perks, like for example, updating is very trivial. If you're not masochistic, then this should sound like heaven to you, because anyone who loves pain would love to update their entire system every time. And well, if you're like me and you like to try software for about 30 seconds at a time, and believe me, I love to try software, then Docker is a great solution for you. Docker has a bunch of containers. These containers sit on a ship, or at least that's what your grandpa would tell you if your grandpa explained Docker to you. In the most simplest terms possible, and this is a huge oversimplification, Docker has a thing called containers. Containers are like these little boxes, and these little boxes, they hold things. They hold images, and these images are so cool because you can have like a little mini operating system right inside of your container, and it's all isolated from your system, and it's great. Initially, Docker was built as an abstraction layer on top of Linux containers, which is LXC. And LXC was just a API for the containment features within Linux anyway. Starting in Docker 0.9, LXC was not a part of the default anymore, and since then, it's been replaced with a custom library called libcontainer, which was written in Go. Overall, libcontainer's advantages: a more consistent interface to the kernel across various Linux distributions. The only gotcha is that it requires Linux 3.8 or higher. So Docker actually shares the kernel, and so what that also means is that we can share the system resources across all of the containers. I'm pretty sure there's features within Docker that allow you to limit how much resources the container is allowed to use, or allocate certain things, or allocate many different parts of the computer to it. Maybe you want to pass through PCI or do something cool, you can totally do that. And so containers are really lightweight since they share the same kernel. And what you end up getting is a very minimal distribution of something like Linux, for example. And you can run these little mini Linux containers on your machine. And it's like a lightweight virtual environment that provides like isolation from other components of your computer. And what it does is it guarantees us that those processes cannot see other processes outside of its container. So containers have images, and these images are easier to think of like mini ISOs in a way. If you're familiar with like how you install an operating system, you might be familiar with ISO. Hook up your ISO, do as you please with installing your operating system. And that's pretty much the bare bone basics of it. So you can pretty much run just about anything you can imagine within an isolated environment using Docker. You know what? Let me just show you about Docker. How about that? In fact, Docker's so easy to install that we can just go to their website and click one button. Like, why would you not install this? You can just go over to the Docker website and just click download. It's that easy. So I'm on Windows, so I'm gonna click on Windows. And after a simple install, when you're greeted with the installation, you're gonna see something like this. And it's actually pretty simple. So first things first. Okay, so when you're installing Docker, you're gonna be prompted with an option for WSL2. If you appreciate your time, you can keep this enabled. This is going to make it start quicker, and there's like a couple other benefits that are that come with Linux that are also going to come with this. All you have to do is just leave it alone. And if you're one of those people who like building shelves on their desktops, you know who I'm talking about, then leave the desktop option enabled. But if you're like me and you don't like pain, you can just uncheck it. Oh, monster! Yeah, cry me a river. Okay, and then that's pretty much it. You're just gonna install Docker. It's that easy. Look at that, it's done. Click close, and you're finished. So it looks like I've clicked this twice. I'm just gonna close this out. And if you search for Docker, you'll find Docker Desktop. Very simple. Just open it. Docker subscription service agreement. Basically, you're just agreeing to sell your soul. No, I'm just joking, maybe. So basically, if you're a huge company and you're making lots of money, like if you're rolling in that dough, then hey, you have to pay for Docker. Otherwise, just whatever. Just click accept. It's going to be okay. Docker is free, by the way. Then if you're into giving away all of your personal information, which is something that we preach against here, then you may fill out your survey to let Docker know all about you and how to tailor things for you. And if that sounds really appealing, please continue to give away your information. I'm going to skip the survey. Thank you, Docker, for understanding. You might also notice that I am logged in to Docker. You are probably not going to be logged in unless you're already logged into the website. You do not need to sign in to use Docker, so it's going to tell you something about signing in. Don't worry about it. Head over to DockerHub, and what you're going to do, yes, I see NGINX here at the bottom of the page, but we're going to search for it just in case it isn't there when you come here. And this should work on any version of Docker, whether if this video was 3 years in the past or just a couple minutes ago whenever you decided to watch it. You can just search for NGINX. And what we end up getting, so we get a list of different NGINX Docker images, and we can pick one to install. So let's just pick this top one here, NGINX. Then we have Docker pull NGINX. And where does our heart go? Right out to that command line. So let's get a command line. So here's what I've got here. I've got a blank command line using git bash on Windows. And so these commands are the exact same on your machine. So you can say docker pull nginx. And when you do this, a lot of magic is about to happen here. We're about to see how fast my internet is too. But you're going to pull an image from Docker. Look at that, we already have it. So now, if we want to run our Docker image, then run inside of your terminal. Say docker run. We're going to specify a port, and I'll put links to the documentation in the description. But here we are just getting started. Port 80 to 80. So this means that we are going to map port 80 on our host machine to port 80 inside of the Docker container. Since NGINX uses port 80, since it is a web server, then we will be able to connect to NGINX, which is going to be the default welcome to NGINX nonsense page, but we'll do some cool stuff eventually. And then just say NGINX. And what you're going to see is that we have attached ourselves to the terminal for NGINX. And if we go to our browser and we go to localhost, if you go to localhost, you can see NGINX and you have successfully run it. To terminate the server, we can always just run Control-C and you will get out. Or if you're using Docker Desktop, you will see that now we have this sleepy Ardingheli. I don't know. Docker picks some weird names. But you can actually play around with this. You can see the logs, you can go to inspect, you can go to bind, you can execute things, you can play around with the files, you can modify the files of your system, because really this is a little mini Linux running within Docker. So you can just play around with it to your heart's content. And then if we go to the images tab, you'll see that here we have NGINX. Here's another option where you can like run things directly from here. I don't personally use the command. I don't use the GUI a lot. I think that it's very important for you to learn the command line. However, if you want to play around with the GUI because it helps you in accelerating you through learning Docker, then go ahead. Here you have an option to also delete your image. And here's some volumes if you create a volume, because in Docker, when we shut this down, everything we do is going to go away. And when we bring it back, it's going to be back in the original state that the image was in. Now, if we wanted to persist our files, you're going to have to create a volume. So to shut it down, what you're going to have to do is you're going to have to go to stop. Or if you're on command line, I will show you. Since we've already run this on command line, we can just Control-C. And here you'll see that we have a status of exited in the background. So if I move this out of the way and we take a look, it has been exited, last started 3 minutes ago. You can go to images, you will see that it's still in use. And if we take a look, it's because we're using it here. So let's clean this up. So to clean up all of the old Docker files, so let's say you're not using your images anymore, you've already shut down those containers. So if we want to clean up old containers, we can just do docker container prune, and then you'll see this will remove all stopped containers. So we'll say yes, and you will now see that it has been removed in the background. And then we can say docker image prune. And what this will do is this will remove any unused images as well. Keep in mind that if you do remove these, you will have to re-download them again. So take a look at the size, determine for yourself whether if having dangling images is worth it to you or not. To me, my network connection is fast enough that I would rather just go and get a fresh copy if I were to ever want this again. So I'm going to run image prune. This will remove all dangling images. Yes. If you get something like this, then you will see that it didn't remove it, even though it's not being used. So what we can do is we can just say -a. This will remove any with at least one container associated with them. Say yes. you will see that it will remove any containers with at least one container associated with them, which is what we want. We don't want any of that stuff on our system, and most tutorials will not teach you how to clean up these files on your computer, so your hard drive space will forever expand. So you're welcome. I am here thinking about you, teaching you how to do things so that you know how to take care of yourself and your file system. So you are now cleaned up completely from this tutorial. Feel free, take yourself to DockerHub, right? Go look around, see what there is, right? And go try to run some of the containers. And have some fun with it. Docker is such a fun system. In the next Docker video that we make, we will end up also learning Docker Compose. So in that case, we'll learn how Docker Compose works and how to use it to simplify this process even further, rather instead running it from the command line. And if you're fortunate enough to join me for the first time as these are being posted, just stay on the lookout. I can only create so much content at one time. So yeah, let's go get some coffee.